Hey, welcome to the Explainer. We're all in this race against time, right? But what if some animals have already figured out how to win? Today, we're going to dig into the secrets of a super long life, and we're learning from the real masters of survival.
All right, let me just throw this out there. How can an animal live for over 500 years? I mean, seriously, half a millennium. What kind of biological secrets do you need to have to watch centuries just roll on by?
And get this isn't just some hypothetical question. 507. That is the actual staggering age of the oldest ocean quahog clam ever found. To put that in perspective, this thing was born when Da Vinci was painting the Mona Lisa. No joke. This one little clam just blows the doors open on what's possible, and it really sets the stage for what we're about to explore.
All right, so here's our game plan for today. We're going to look at 3 main strategies these animals have mastered. First, simply evading danger. Second, slowing everything way down. And third, building better, tougher cells from the inside out. Then we'll wrap it all up with what we can call the longevity blueprint.
Okay, let's jump right into strategy number 1, evade danger. And I mean, this is about as basic as it gets, right? You can't live a long life if you get eaten. Sounds super obvious, but the effect this has on evolution is just massive.
So check this out. On one hand, you've got a mouse. It's lucky if it sees its second birthday. But then you have the naked mole rat, which is about the same size, and it can live for 30 years or more. So what gives? How is that even possible? Well, it all boils down to their very different lifestyles.
And this is the key. Once you take away that constant pressure of being hunted, evolution gets to play a totally different game. The naked mole rats, they just went underground. Bats, they took to the sky. And once you're not worried about getting eaten every second, you don't have to reproduce like crazy. Instead, your body can start investing all that energy into a new project, longevity.
Then you've got animals that go in the complete opposite direction. Take the giant tortoise. It's not hiding, it's not flying away. Nope, it's using what you might call the fortress strategy. It's basically a walking tank. It's so big and so well armored that most predators just look at it and think, yeah, not worth the effort.
Okay, so you've figured out how not to get eaten. What's next? Well, it turns out the next big secret isn't about outside dangers, but about what's happening on the inside. Strategy number 2 is all about slowing things down. The pace of life really is the pace of aging.
And you see this pop up in all sorts of cool ways. You've got the kakapo parrot, which has this really slow metabolism, meaning less wear and tear on its cells. Then there are bats, which use hibernation and torpor. It's almost like hitting the pause button on life. And for animals in the Arctic, like whales and sharks, the freezing cold water does the work for them, acting like a natural cryochamber that just slows everything down.
I mean, just look at the effect of living in the cold. It's absolutely mind-blowing. The bowhead whale can live for 200 years. The Greenland shark, a whopping 400 years. And then our old friend, the ocean quahog, clocking in at over 500. It's pretty clear that living in a giant natural refrigerator is a huge part of the secret sauce for an ultra-long life.
All right, so you've dodged predators, and you've slowed your metabolism to a crawl, but there's still one big enemy left, decay from the inside out. And that brings us to our third and maybe most fascinating strategy, building better cells. This is where we get into the deep science.
So let's go back to our buddy, the naked mole rat, for a second. Turns out, living underground isn't its only trick. These things are basically cancer-proof. It's wild. Their bodies are just flooded with these anti-cancer compounds, and they have this special biomolecule that basically cuts off the food supply to any cancer cells before they can even get started.
Now, the bowhead whale has a different but just as incredible solution. It has a genetic off switch for cancer. As it gets older, its body can literally turn off the genes that cause cells to grow and turn on the genes that stop them from going haywire. I love this quote from aging researcher Juan Manuel Vasquez. He says, "It's like the emergency brake on a car. Their genes can just slam on the brakes and stop cancer cold." Can you imagine having that built-in safety feature just keeping you going for 200 years? And finally, let's look at the Greenland shark. Its whole strategy is about amazing maintenance. Look, if you're going to live for 400 years, your DNA is going to take a beating. So what's the shark's solution? It's simple. Have a ton of backup copies of your repair genes.
And here's another great analogy from Vasquez. He says, having more copies means you have a lot of spare tires in case something goes wrong. One gene gets a flat, no big deal. Just swap in a spare. It's how they keep their genetic blueprint in perfect shape for literally centuries.
Okay, so we've looked at dodging danger, slowing down time, and building bulletproof cells. So what does this all add up to? What is the actual blueprint for living a ridiculously long life?
Well, as you can see, it's pretty clear there's no single magic bullet. It's really a combination of all three of these powerhouse strategies. You have to be good at evading danger, you need to have a slow, efficient metabolism, and you need to have these incredibly tough cells that can fight off decay from the inside.
So, when you boil it all down, it comes to these three pillars. To achieve extreme longevity, you have to win the war on three different fronts. You have to beat the external threats, you have to perfectly manage your internal energy, and you have to win that constant, microscopic battle against decay happening inside your cell.
And all of this leaves us with one big final question, right? These animals figured this stuff out over millions of years of evolution. It's literally written into their DNA. So as we start to finally understand their secrets, what can they teach us about our own race against time?